Thanks, Karen. Good morning, everyone. I'm Dave Theobald from Conservation Science Partners. We're a newly formed NGO, also from Colorado State University. I'm going to actually build on a bit of what Earl talked about. We do a lot of conservation science, conservation work, where we look at big landscapes. This is the Great Northern LCC, so this is transboundary in basically northwest into Canada. Wanted to talk about a couple of ways that we're currently using Google Earth Engine. One that I'm not going to mention is, or not going to talk about today, is the methane mapping, mapping methane leaks in urban areas. Anyway, so this workflow I felt was very important. When I was here about, I guess back in August, I had trouble trying to figure out how I was going to think about the workflow, and so I sort of laid this out. So this is how we think of it, our existing tools and data sets. I'm going to talk about some landform work where we directly use it in Google Earth Engine, and then talk about this glued exercise. So first of all, one of the questions that we're working on is there's been a lot of talk about all the remote sensing and the dynamics of the Earth. There's a lot of things that don't change very much on the Earth, and it's very important to capture that as well as the platform. And so what places are going to be resilient to climate change, for example? So in conservation biology, there's a lot of talk about land facets. This is a representation of that. So how do we capture basic landforms that are relatively static? So I had programmed this in ArcGIS. Before I got here at one of the training centers, I basically reprogrammed it, and to my delight, it ran really well, so I basically reproduced it for the US right now. So it's enabled us to go broader and finer and faster. We're able to go from ecoregions up to US and actually global now. Being able to go from, roughly a kilometer resolution down to 10-meter resolution, which is incredibly important for these kinds of things, and going from 2 months to 2 days, or maybe even 2 hours in terms of time to do this. So it's been transformative for us. A second effort is to think about how to coordinate land use and land cover efforts to monitor landscapes globally. Most monitoring, at least in the US, of resources is specific resource based. Let's monitor the trees, let's monitor the soil, let's monitor the water, let's monitor the air. There's nothing integrative, and yet that's what we're all struggling with. So one of the things that I've been working on is this thing I call the global grid. It's a flexible, globally comprehensive and consistent sample design. It uses something called a spatially balanced sample design. I don't know if you can see the little black dots there. Those are just sort of little measle dots all over the place. There it is, 1 minute. And we have a bunch of common response variables that we record. This is what it looks like. We're using it for a variety of currently funded projects right now. You see down in the west, farmlands, riparian ecosystems. We've got a process worked out. We're collecting these data in Google Earth, spreadsheets, bringing those data back into it, using for training data, and also for probability-based sampling. So we call this effort called the GLUED, Global Land Use and Cover, but it didn't fall into my acronym very well, but GLUED, Emergent Database. And we think of it as beyond citizen science. It's getting professionals working together. So why are we all building different data sets when we're measuring very similar, the same kinds of things? Let's leverage each other's work. So that's the hoop. That's the hope. And if you want some more information, contact me here. I've got a Google group starting to work. So thanks very much. Yeah, so for the landforms, what kind of data are used? Right now, they're simply digital elevation models. So I do a topographic position index. I look at slope. I look at a continuous heat load index. For physiographic diversity, we also bring in soils. So so that's another important element. So what we're looking at is abiotic, things that are static, basically, so that we can use that as a platform for all the dynamic and changing things. Those are very relevant to our managers, we found.